Today we're going to be learning about graphing the standard form for the second day. So the first thing we're going to do is look at equivalent expressions. That means that we're going to complete each row with an equivalent expression in standard form or factored form. So if we have x squared, what does that actually mean? That means that we are taking x and multiplying it by itself. So that would be the factored form. If I give you the factored form x times the quantity x plus 9, then we would distribute that x in and get x squared plus 9x. If we have x squared minus 18x and we're looking at what those have in common, they have an x in common. Left-hand side is x minus 18. X times the quantity 6 minus x would give us 6x minus x squared. You could also write that as negative x squared plus 6x if you want. Negative x squared plus 10x, we're going to bring a negative x out front, and left would be x plus 10. And the last one, if we have negative x times the quantity x plus 2 and 75/100, we get negative x squared minus 2 and 75/100 x. All right, so that's what we get there. And then the question asks us, what do the quadratic expressions in each column have in common? So obviously we know that these are all in the left column, these are all in the right column. That's not what we're talking about. And these are all in standard form and these are in factored form. That's not what we're talking about. But how do they compare? So if we're looking here on the left, all of them have an x squared term, and then they have, some of them have, or most of them have some sort of linear term, but none of them have a constant term. On the right-hand side here, we're noticing that each of them has some sort of factor of x, whether it's a positive x or negative x, depends on the question. And then the other part is just x plus or minus some sort of number. Okay, so that's what we notice there. So the next thing we're going to do is kind of look to see what the linear term actually does to the graph of this. So it asks us to graph y equals x squared and then experiment by adding different linear terms for to this and record our observations. So I've already done this here where I typed some of the values here. I'm actually going to move it over here. Some of the values that they gave us in the question. So I have y equals x squared. That's the red function. Y equals x squared plus 4x. That's the blue. We have x squared plus 7x, which is the green. And y equals x squared minus 9x is the purple. So we're looking from the parent function, seeing what happens. So I'm actually going to kind of turn these other ones off for a second. If we're looking at the original and then we're looking at x squared plus 4x, it's taking that, it's still going through the origin, it's still going through 0, 0, but over here it's going through the point negative 4, 0. So where do you think that came from? So here, if we took a GCF of x out, that would give us x times the quantity x plus 4, and then based on what we've been talking about previous days, that plus 4 would move over as we're solving it and get to be negative 4. Same thing happens here, that it still crosses the origin, and then it crosses at negative 7, 0. And for x squared minus 9x, it crosses through the origin and also crosses through positive 9. So kind of this number here, it's going to cross through the opposite of that when x squared is positive. Okay? So then what happens if we have negative x squared? So if we look at that, so I'm changing all of these here to be negative x squared functions. Okay, so same graph again. We have the parent function of negative x squared, and then I just kept those same ones that we had yesterday, that we had in the previous example, but I just made them all be negative x squared instead. Okay, so if we're kind of looking at these individually, let me turn off some of these. Here we have our y equals x squared in the red, and then y equals negative x squared plus 4x. So that's going through the origin of 0, 0, but it's also going through the point 4, 0. Okay, So why is it the case then that this is positive 4, that's positive 4, but in the question we had, like in the previous questions, we changed the sign of it. So if we're looking here, we would take out a GCF of negative x, and that's going to leave us with x minus 4 inside, which we would have to add the 4 over to get us 4. So that's the big thing we're noticing here. Let's see if it works on the other one, on another one. So here we cross at the origin, and now we cross at positive 7x, which we have here. And then the last one, let's see if it works there as well. If we turn that function on, it crosses at the origin, and then it also crosses at negative 9 because negative 10 is over here. Okay, so things to keep in mind: if you have x squared plus or minus some sort of number, it's going to be the opposite of that linear term. So here it would be negative 4, 0, negative 20, 0, positive 50, 0, and so forth. And if it's negative x squared, that linear term is going to be just that number. So it would be positive 4, 0, positive 20, 0, or negative 50, 0, and so forth and so on. All right, so let's use that to our advantage here and answer some more questions. Okay, so what we're going to do is look here at this table, and we have 4 different situations that we're in. Okay, so we've got our equation. We want to build our x-intercepts and then talk about the x-coordinate of the vertex. So since we have x squared plus 6x, remember all of these went through 0, 0, that origin. That's coming from the GCF of x that you could take out to look at factored form. And then since this is a positive x squared, I'm going to change that to be negative 6, 0. The x-coordinate is going to be halfway in between those two things. So from 0 to negative 6, halfway in between those is a negative 3. X squared minus 10x, again, we're going to have 0, 0 as one of our x-intercepts. Since this is negative 10, our x-intercept is going to be a positive 10, 0, which means the x-intercept halfway in between 0 and 10 is 5. Here, now we're going to be careful. This is negative x squared plus 50x, which means we're still going through the origin of 0, 0 because we have no constant term. And this is going to go through positive 50, 0 since this x squared is negative. That means our x-coordinate halfway between 0 and 50 is 25. Negative x squared, negative 36x goes through the origin and also goes through negative 36, 0. Halfway in between those two would be an x-coordinate of, negative 18. Okay? So some quadratic expressions have no linear terms. So here we have just a quadratic term and a constant term. We want to find the x-intercepts and the x-coordinate of the vertex of the graph representing each equation. So it is possible for the graph not to intersect the x-axis, and we can always try graphing them. So let's go ahead and do that. Let me pull up the graph here again. We're going to graph y equals x squared minus 25. So we're looking at this, okay? And we're crossing at negative 5, 0, and 5, 0. Those are our x-intercepts. And so those are the x-intercepts, and the x-coordinate is happening halfway in between those, which is at 0. Okay? If we look at x squared plus 16, so here I have that typed in. We're looking at the graph of it, so I did have to adjust my window to see all of it. Here it's not crossing the x-axis, so there are no x-intercepts. Okay, and then the x-coordinate of the vertex is happening there on the y-axis, so the x-coordinate of the vertex would also be 0. Okay? So then let's take a look here at trying to build some equations for graphs. All right, we're going to kind of look at them 2 by 2. So it says use graphing technology to find a graph that matches each given graph. Make sure your graph goes through all 3 points shown. All right, so if we have this that goes at the origin and at -1, +1, and +1, +1, we know that we need a quadratic term. It's facing up, and if we just look at this, 1 squared is 1, and -1 squared is also 1. So this is our function. And you can type that into Desmos to double check that it's correct. Here, we know we're going to have, we have 2 different x-intercepts. Since we have x-intercepts, it's actually easier to use the factored form of this. So if we have -3, that means we're going to have x plus 3. And since we have a +3, we're going to have x minus 3 in our parentheses. And again, we could check these in Desmos to make sure that they're actually correct. Okay. Moving down here, for letter C, we have y equals the first x-intercept of -2 would go into the parentheses as x plus 2. And then we would have x minus 3 for this other one. So on this, let me show you what's happening here. If you do type this in, so you have y equals x plus 2 and x minus 3. Okay, and then you can look at these different values, so it does give us this point on there as well, so we know we're good to go. Okay, so that's how you would work on checking your answers. All right, here we know that we are crossing at the origin, so that's just going to be an x, and for -6 we would make that be x plus 6. This is one of those that since it crosses through the origin and then crosses through some other point, you could write it in the standard form where it would be y equals x squared plus 6x. Either one works, it doesn't matter. Okay, let's look at a few more here. All right, so letter E. Now we notice that this one does cross at -2, which would give us a +2, and +2, which would give us a -2 in our parentheses. But it's facing down, so what does that mean about this? That means that we need a negative out front. Okay, so it's facing down, it definitely needs a negative out front. And you could check those again in Desmos. All right, on this one, it is a parabola, so we do need 2 sets of parentheses. But how are we going to make this work? That's only a linear function. We need to make it be the case that we're getting something squared if we were to multiply them together. That means we need 2 parentheses here. Well, if we're trying to plug in 0 and get a +4, so we're plugging in 0 for x, 0 minus 2 is -2. -2 times what would give us that +4? Well, that's a -2. That means that we have a multiplicity of this x-intercept, okay? Next one, we have y equals, we know it's facing down, and this is going to give us x plus 1. This +3 is going to give us x minus 3. And the last one for now, we have y equals, it's facing up, so it can be positive, x minus 1 from this +1, and x minus 5 from this +5. And again, you can type these into the calculator to double check that they work. Okay, that's it.